Hi, everybody. Today is our second day on function notation, and you can almost think of today as like an add-on to our last topic. Really, what we're going to do is we're going to address function notation, assuming that you have a decent background and viewing it as substitution and some operations. We're just going to see maybe some other areas where we can use function notation. And then we're going to finish off today. I'm going to throw a doozy at you for anybody who's looking for a little bit of a challenge. So let's take a look at the screen. This is one of those days where you're going to want to copy down everything you see on the screen and then be able to work through on your own. So there's going to be quite a few times today where I'm going to say to pause the video. I think we should be good to do that today. So let's take a look at problem 1. If f of x equals 2x minus 3 and g of x equals 1 minus 4x, find a value of x that satisfies each of those. So let's start off with A. I think we should be good to jump in and try to tackle A. So come up with a solution for A. Pause the video now. Okay, and we're back. So I'm hoping that we were good to just follow that function notation, and it says to have f of x, which is my 2x minus 3, equal g of x, which is 1 minus 4x. And notice that in this context, unlike last time we only dealt with expressions. Today, I follow that function notation in A, and I ended up building an equation. Now, that equation can be solved, so we can go ahead and get x all by itself. So I'm going to isolate, and maybe I've got 6x's on the left, because to get rid of a minus 4x, I can add 4x. That means I want to get rid of that minus 3, so I can add 3. And I can divide out, because to get rid of a multiply by 6, I can divide by 6. And we should be good to reduce that in one step. So hopefully we match up. Notice the red and the blue was me interpreting function notation. The purple then just became background algebraic skills. So hopefully not too bad for us. Okay, now that we've walked through A, I think everybody should feel a whole lot better about B. So I want everyone to pause the video and work their way through B. Okay, we're back. Now, we notice in B that that's telling us to take f of x plus 1 and set it equal to g of x minus 1. So I have some substitutions that I have to deal with. So on my first line, I'm going to deal with the whole first line. That I need to take x plus 1 and sub it back into f wherever I saw my variable. So replace my x with x plus 1. On the left side of that equal sign, there is f of x plus 1. Now, on the right side, I need to find g of x minus 1. So I need to sub x minus 1 back into g wherever I see my variable. And so that red line then is going to give you a little bit of information. It's going to act as your gauge to do I understand my function notation. After that, we've just got straight algebra. This is now, can I solve an equation? I would recommend for you to maybe put in that line. Let's expand our brackets. I would even recommend that I don't think it's a bad idea to simplify each side. Now we can go through the process. I'm able to isolate my variables. So to get rid of a minus 4x, I can add 4x. That means to get rid of a minus 1, I need to add 1. Oh, and look at that. That works out nice and neat. And there's my x value of 1. So as I said before, red gives you function notation, or acts as a gauge for that. The purple is going to be, hey, are you good at being able to solve a linear equation? Okay, let's keep it going. I've just copied out the information from question 1 just so we can have it on the screen again. And I'd like you to be able to work your way through C. So I'm just going to shrink it down to make sure that I have lots of room to work. But I would like you to go through and figure out C. Okay? Pause it now. Okay, we're back. So I can go through. On the left side, it says take 2f of 4x. So I need to multiply all of my f by 2, while at the same time replacing my x with 4x. So you'll notice what I have in red. I replaced my x in f with 4x, and then multiplied that whole result by 2. Okay, on the right side, that one's a little more direct. I just need to take g of x and multiply it by 3. So there's my function notation. I'm just going to switch into blue for all the rest of my mechanics. I don't think it should be a bad thing for us to take a look on the inside and say, well, there's a 2 times 4x, so that's an 8x. Double it. Double my negative 3. There's me expanding my 2 in. On the right side, that's a straight expansion. If I get my x's onto one side, I've got 28x, and if I get my constants onto the other, I've got 9. And when I divide out my 28, that will not reduce. And so I come in on 9/28 as my perfect answer. Okay, hopefully that wasn't too bad, and we were pretty comfortable to now just see function notation in a little bit of a different setting. That maybe I'm just not working with expressions, but I'm actually able to work with equations and build equations as well. Okay, let's take a look at our next section. So this is problem 2, and I'd recommend that, you pause the video anytime you need to be able to copy down that problem. In problem 2, f of x is going to equal 3x minus 5. And now I'm being pretty explicit when I say solve a. So just make a note that as soon as that instruction says solve, then we should know that we are going to build an equation. Okay, so I would like you to be able to work your way through and figure out A. Pause the video now. Okay, and we're back. So to take a look at A, I think this should have been pretty automatic. It says f of x squared. So f of x is 3x minus 5. Square it. There's my equation. My job is to now solve for x. Now, what I'd like to do is I'd like to maybe walk through 2 ways that you may have dealt with this. I personally think one way is better, but you might at the end look at them and say, they're pretty comparable. I'm going to bet and say that I have a large group that would have gone through and dealt with this blue solution. That is, you see the left side of that equal sign, and we spend a line expanding it. So square the 3x, multiply them together, double it, square the 5. And now we build that equation. You can't put your variables into one variable term, so get everything to one side of the equal sign. Maybe you take a look at all 3 of those terms and you recognize that there's a common factor of 3 in there. So we're going to divide out a 3 from all of those terms. Now for me to solve that quadratic equation, I would really love it if it factored. And so I have 2 numbers that multiply to give 3, 2 numbers that multiply to give 7. I need to get a negative 10. So if both of those are negatives, that works, and that matches with my positive 7. Put in my brackets and my variables. And that allows us to now say, well, therefore, x equals 7/3 from my first factor, or 1 from my second. There we go. Not too bad. We happen to get 2 values for our x. Good. I would have expected that if I was to walk around the room and you were in front of me, we would probably see a large number of you that have that blue solution. And I'm going to take blame on behalf of all of your math teachers, because I think that there can be some times where we almost build up this instinct of, I see brackets, I expand. However, I want us to notice that nowhere in this problem did it ever tell me to expand. that that was an action we chose to take as part of the solving process. And maybe we even just expanded those brackets because we weren't sure what else to do. And we knew that we could do that operation. However, if you look back at that red equation, I want you to notice that my x is in one spot. And I should be good to be able to solve equations where my variable is in one spot. I just have to isolate it. So that action to go through and expand the brackets is what caused the variable to now go into two terms. Those two terms I could not collect. And so it forced me to have to put it in standard form, to factor, and to solve. Maybe there was more work there than what was needed. So I'm going to draw a little green arrow over here because I think this would be the preferred solution. If I have, and I'm just going to write that down again so we can see it in detail and not get it so jumbled up with the blue. That if I have 3x minus 5 all squared, and that is now equal to 4, there's my variable. Just get it by itself. So our job should be to isolate that variable. So what's the first thing we want to get rid of is probably that squared. I can eliminate that squared by taking the square root of both sides. That means that the squared on the left is gone. And when I take the square root on the right side, I just have to remember that every time I choose to take the square root, I get two answers, a plus or a minus. And the square root of 4, there's my 2. Okay, so what that tells me is I'm going to get two answers. That I could now have this equation, 3x minus 5 equals positive 2, or I could have this equation, 3x minus 5 equals negative 2. However, you look at those two green equations, and those should be like the easiest equations of life to solve. Get rid of your minus 5, divide out your 3. Get rid of your minus 5, divide out your 3. And there are our two solutions. Now, I just don't like how sloppy that first one is. There we go. So, had I gone through and been given this problem, I would have solved it using the green method. That if I have the option to simply isolate a variable, I will. That I don't like to expand it and now create a situation where I can't put my variables together into one variable term. So, as I said, I would have guessed that I would have seen an awful lot of blue solution. Maybe it didn't even think of that green as a viable option. Maybe that's just another strategy that we can put in our back pocket. Okay, hopefully not too bad. Let's jump into the next problem. Okay, this is the same number 2. I've just copied that original function back out so we can see it on the screen together. And there is question B. I'd like you to find when f of x plus 1 equals f of x minus 1. Okay, go ahead, pause the video now, see what you can come up with. Okay, and we're back. So, if we started off interpreting our function notation, I need to replace my x with an x plus 1 in f. And then on the other side of the equal sign, I need to replace my x with x minus 1. So that's going to give me that equation. Now I just need to solve it. So maybe I put the blinders on and I just go through and I expand my brackets. And maybe I collect like terms. And I think we might hit a snag right there. Okay, there are a number of ways for us to be able to talk about this situation that arises. And there's a number of spots in our solution where we might come to this determination. I'm going to maybe put the blinders on a little bit, and I'm going to go through, and maybe I recognize that my 3x's cancel out. that I may get the equation right now of -2 equals -8. Or maybe I keep going on that line and I get all my x's on one side, so it's a 0x, and I get all my constants on the other side, so it's a -6. And maybe I can make my determination from that line. I would hope that we didn't have to get down to this point, that I would argue that we really have the blinders on if we were just trucking through and said, okay, well, to get rid of a times by 0, I divide by 0, and we come in on that line. But hey, if we got to there, we should still be. Well, you take a look, and either at the moment we had the green, or the moment we got to the gold star, or the moment we got to the purple star, we should have been able to determine that there is no solution to this equation. So everyone's answer at some point is no solution. The equation that was built in red has no possible solution where you could sub in that x value on the left and the right side and make left and right side equal. Okay, how do we get to that determination? Well, at the very least, if we look at the purple starred line, we should be good that -6 divided by 0 would be an undefined value. And since we come to an undefined value, then therefore the equation that gave us that has no solution. Okay, can we take a look back up at the gold starred line? I hope that we can see what I am boxing in has no solution. That says 0 times something gives us -6. 0 times something gives us -6. Well, we should be good that that has no possible solution. There is no something I could put in there because 0 times anything gives me 0. And so on that line, we could have made the determination, no solution. Okay, can we backtrack up to the green line? I would hope that if we took a look at that green line, we could see that that equation would have no solution either. Like, explicitly read out loud to yourself what that green line says. Like, take a moment right now and read it out loud. It says -2 is equal to -8. No, it's not. That's an incorrect statement. So, therefore, the equation that gave us that does not have a solution to it. So, at any of those points, the purple star, maybe the gold star, or the green, I would really love it, though, that if it was at this point or at this point that we came to that determination. But at any of those points, we should be good to state that there actually is no solution to that equation. There is no x value we could sub back into the red to have left side equal right side. Okay, I'm going to argue to us that's the end of our function notation kind of topic for today. Now, as you look back over the course of this lesson, I hope that function notation was a breeze, and that first line that we were writing down, interpreting our function notation, went pretty smoothly. That actually, as you take a look at the rest of this topic, today's topic should have almost acted like an equation review. Okay, solving some linear equations in problem 1. And now in problem 2, well, we had to solve a quadratic equation, potentially, if we expanded. Therefore, we had to remember that we could factor that to solve. If it didn't factor, we'd use quadratic formula. Gee, I wonder if we remember what that is. Or maybe it gave us an alternate way to go through and solve that equation. And now you take a look at 2b on the screen and we notice, oh, well, what happens if we get a no solution to an equation? So I'm hoping that the rest of this topic really felt like an equation review for you. Okay, I told you at the very beginning I was going to leave you with a bit of a stumper. Here it is. So this is kind of the mindset that I'd like you to have, is that if you were struggling on function notation, that we didn't really have down being able to interpret that notation and create equations or functions, then I don't know whether working on this stumper is for you yet. Maybe we should be going through and we should be getting extra practice at working on just the mechanics. However, if all of that stuff went pretty smoothly, then I might recommend jumping in and playing around with this. It is a stumper, it's a doozy. So by no means do I think you're gonna look at it and go, oh, there's the answer. No, it's gonna take some work. It's probably gonna take some struggle. It might take a little bit of time, like maybe I come back and take a look at it tomorrow or so on. So you figure out where you best should spend your time. Do I need mechanical practice? If so, I'm gonna go and I'm gonna work on some of that practice. If I don't, then maybe I'm gonna spend some time playing around on this stumper. Okay, what is the stumper? Problem 3 asks you to let f be a function defined by, and now there's your big ugly function. I'm just gonna circle it in red, or box it in, so that we can clearly see it in there. That function says f of n equals 2 f of n minus 1 plus 3 f of n minus 2. And then it tells me some stuff afterwards. It tells me that f of 1 equals 1 and f of 2 equals 2. The question itself wants me to determine the value of f of 5. So you've actually solved this problem if you can find what f of 5 is equal to. Of course, when you find it, it needs to be fully simplified. Okay, there is your doozy. So, as I spoke about earlier, you find out the best way for you to spend your time. And if that is playing around with this one, good luck. Otherwise, we're jumping in, we're getting some extra practice on our mechanics, and then we should be good to kind of change gears next time. Okay, best of luck.